Assalamu alaikum. Hello, everybody. Thank you so much for joining the second day of our workshop. Also, I want to thank our keynote speaker, Dr. Nasser Hassan, for accepting the invitation and giving us this workshop before Iftar. So thank you, Dr. Nasser, so much. Also, I want to announce that this workshop is already live on YouTube as well and recorded. Before we start, Dr. Nasser, he will continue the second day of this workshop, and after this workshop, I don't know, Dr. Nasser, do you want the question during the webinar, or you want after it is up to you? But please don't write the questions in the chat because the chat is keep rolling. If you have any question, just write in the Q&A, or you can raise your hand and we can go one by one after Dr. Nasser workshop. Thank you so much for joining us. Dr. Nasser, the floor is yours. Thank you.
Thank you so much, Dr. Ahmed, again. And hello, everyone, and welcome to the second day of this workshop and the final day as well. So just starting from where you ended your talk, Dr. Ahmed, I prefer asking the questions just after going through some of the materials. So whenever I ask if someone has any questions or not, you can just raise your hand and ask your question, and maybe you can type it also in the Q&A. I found this very efficient way to ask questions as well. Okay, so before starting today's lecture, let me just share my screen. I am going to share a link that contains today's material, so you can download the data sets that we are going to use for today's workshop. Let me try to do this, people. Okay, and you guys should be able to download the material, and let me know if you can't. Okay, so while you guys are downloading this material, so yesterday Dr. Ahmed raised a very important question that is about the difference between different statistical software such as Stata maybe, or SAS or SPSS compared to R, and whether one should use R rather than the others or not. So I will be super conservative and super democratic answering this question, Dr. Ahmed. So I think the answer for this question is depends mainly on you. So if you are proficient with R or maybe SPSS, and SPSS can do all of your work with no problems, so you can always do your work with SPSS if it's sufficient. And if not, if you want to do some simulation studies, if you want to fit some models that cannot be done in SPSS, like for example in my field of area, in my field of work, I do some models that cannot be fitted in any other software rather than ours. For example, we cannot do like congeneric model, tau equivalent models, such stuff in item response theory. So I need to work with R to get these models to be fitted. Otherwise, I have to do it by hand. So it's painful if you want to do it by hand, and this is where you can use R or any other programming language that can give you the chance to play with the model as you like. Another thing about SPSS, SAS and Stata, they do have a lot of defaults when you look at the back end of their way of computation. Do we need to have an account to download the folder? I don't think so. Okay, let me just do this through Google Drive, maybe. This is weird. Oh, I'm sorry. Just hold on a second. Anyone with the link? Okay, now you guys can access the file. Okay, no. Yeah, now you guys can access the file through this link. Sorry. Yeah, so you guys can access the files through this link. Thank you so much, Fatima and Kisinia to raise this up. Okay, so again, the other thing about R, I'm sorry, about SPSS and all the other statistical software rather than R, they have a lot of defaults. So if you are, especially when you got some missing values in your data, you can see that if you use different softwares, you will get different results. So in R, you can mainly deal with everything manually. So there is no defaults in most functions, and you have to specify each procedure to be done, and including how you will deal with missing values or missing data as well. So yeah, I hope this answered your question, Dr. Ahmed, and I don't know if you have any follow-up question. I think this is the main two key differences, I would say, between the two. That is just in conclusion. Yeah, to conclude that, so R basically you can do whatever you want in R, and also the defaults will not force you to do some analysis in a way that you don't want it to be done. So you can manipulate that and play with it as you want, as you like.
Also, if you let me add, Dr. Nasser, also I want to tell our audience that R is also free. If we compare to Stata and SPSS as well. Also, some of, as you said before, yesterday in the beginning of your lecture, that R you can download it in mostly all the systems like Apple and Windows and this stuff. The other programs like SPSS, Stata is not that easy. I need to do several stuff, to download it in the Mac, let's say. Maybe Windows is much easier, but it's not in Apple. But here in R, it's easier. I think this is one of the features.
Yeah, right. Yeah, I totally agree with you. Yes. So yeah, do you guys are you guys able to download the files, or you need some time to do that? If you can type in the chat whether you can access the files now or not. Okay, done. Thank you. You are most welcome. Okay, so I think we are ready to start our workshop for today, and let's move to my working directory. So yesterday when I closed the session, I saved everything, and this is one of the best thing about R. So whenever you close your work, your project, it will ask you to save the working space or not. If you click on save, once you open it or reopen it again, everything will be restored with no problems at all. Sometimes the only thing that might be not stored is the packages. So sometimes you may need to load the packages again, not install them, but to load them again. And this happens just a few times, and for some reason I'm not sure what is it. Okay, so in today's workshop, we are just going to continue what we were doing with the tables, and then we are going to move to analyzing a simple data set. Then we are going to do some hypothesis testing, and in the hypothesis testing, we are going to use 3 different statistical techniques that are just briefly correlation test, t-test, and independent samples t-test, and one-way ANOVA. So these 3 techniques we are going to cover in this lectures, and I hope the time will help us today. So first, let's start with recapping what we learned yesterday, and I would like you guys to create a table that looks like this table in front of you, with a column containing 3 different child names, and a column containing the Arabic grades, and a last column containing an English subject grades. So as a hint, first you need to create each column separately, and just recall how you will be able to create each column separately. So I'll give you 5 minutes for this, and remember that you can use Google if you want to know how you can join the columns together. So 5 minutes starting from now. Okay, so I've got an idea or answer from Najwa, and let's try this. So I'm going to copy that. I think I can not. Let's do this, okay. And moving to RStudio. And by the way, you can see that all of my codes I wrote yesterday are here. So they were stored. Okay, and exercise, sorry. And this is Najwa's response. Okay, so this is what Najwa did. Okay, I can see that there are a few typos here. So as you guys notice, maybe the numbers here are in green. So that means the R is dealing with these numbers as characters. So the reason is because Najwa forget to put the quotation and to close the English grade quotation. Yeah, this is something to pay attention to. And you have to double check it with R. Okay, so let's run this one. So we got the exercise 4 from Najwa, and then she used the matrix function. I will call it exercise, so I will call it Najwa equals matrix 4, just to save it for future use. Okay, so here you go. So you got 4 different rows and 3 columns, and this is not really what we are looking for. So the first row here is just indicating that this is the column name. So we don't want this to be in a one row in R, as in Najwa's case. So again, we got one from Zahia and one from I'm sorry, so for the interruption. So we got from Zahia, this from Zahia or Zahia, and this is I think we got an error here. There is something wrong with this one, Zahia, I guess. So let's try to do this. I think there is a problem with your codes. I don't know what's the problem, Zahia, but doesn't seem that it's going to work. So if you can fix it and then let me know what's the problem with it. And we get from Fatima. I think Fatima is following the way that I want this to be done. Or this is the way how I'm going to do this as well. So this is column 1, 2, 3, and table 4. Could not find. So what's this function? In which package is this function, Fatima? Do you know? Let me try to find it. Function in R. So that's in to dplyr. Oh, so I'm not loading dplyr. It's loading. Okay. Now let's see. Yeah, that's perfect. That's definitely a great idea. So again, the same problem. You got the first row as the yeah, you got the first row with column names. Osama, so the regression with R requires a lot of advanced stuff. So this workshop basically deals with the introduction to R. So if you would like us to do any sort of advanced workshop in the future, I will share a link with you at the end of this workshop to ask you whether you guys need some advanced stuff in R or not. So this is not the case for today's workshop. Okay, so again, the same problem happens. The first row, which contains the column names, is into our data set, and we don't want this to happen. So let's move on my way to answer this question. So I would say Nasser here. First of all, I would like to create a column containing the child's name, and I will call it child. Excuse me. And that will contain the names of Ahmed and Sarah and Noura, and that's the first column. The second column, I will call it Arabic, which contains the grades, and they are 45, 30, and 10. Okay, just minimize this as much as possible, and this as well. Okay, so I don't want to go through this. Let's go to chat. Okay, so this is the second column, and the last column is the English grade. Combine 50, 40, and 1. Okay, so now we got 3 different columns: child, Arabic, and English. Now, how can we join the columns together? Again, you can use Google. So first we create the columns. Then we want to combine the columns. So how can we combine the columns into one data set? There are 2 ways. The first way is through the function data frame. I'm going to show you how to do this. So I will call it data1. So this is my data set name, data1, my new data set name. You can't see data set data1 here in the environment. So that means I'm creating a new data set, and I'm going to call it data1. So this is data1 equals, I'm going to use the data frame function. So data frame, and then just put your column names into it, the vectors that contains, the variables that contains the values you want. Okay, so we got child, we got Arabic, and we got English, and run this. And now you can see that you got 3 different columns with 3 rows, and that's 3 by 3 table. So when you compare this one to the table created by you guys, you can see that the first row contains the column names in your data set, Najwa and I guess Fatima, maybe. I believe so. Yeah, Fatima. However, I want the first row to contain, I don't want the first row to contain my column names. I want the column names to be there. So this is one way to do this. There is also another way to do this through the cbind function. So I'm going to call this data2 cbind. Cbind means just simply column bind. Okay, and again, just include your vectors here, Arabic and English, and run this. Then now you can open up your data too and look at the table. However, I want to show you something really weird about these two tables. So data 1 and data 2. And I want you to notice the difference. So as you can see, this is the first table. The highlighted one is data 1. This is when we use the data frame function. However, the not highlighted one, the below one, is when we use the cbind function. So can you notice the difference between the two? I'm sorry, I have to answer this call. I'm sorry. Yeah, I'm sorry, I have to answer this call. Okay, so yeah. Okay, yeah, so Najla noticed that the numbers are within quotation marks in the second data. So what does that mean? You can, by the way, look at it in the environment. You can see that this table, this data is a vector actually containing characters only. So that means if you want to add 45 to 50, R will not do it for you, because R will assume that 45 is a name and 50 is a name as well, is a character. So you cannot add or subtract or do any calculations with characters. And that's the difference between using the data frame function, which is the best, and cbind only applicable for characters values, or to combine characters as no numbers. So no numbers here. Okay, so any questions so far? Do you guys have any questions so far? And if you guys have any questions, just write it please in the Q&A. You can find a Q&A button and I'll see all of the questions. Otherwise, I'm going to continue. Okay, so let's move on. And you'll get all of the codes here. And okay, so the second thing, we want to create a new column, and that is the total score of Arabic and English grades, and we want to call it total. We want to name this column as total, and we want to store this column in data 1. So to create a new column, creating a new column. First of all, you need to specify in which data set you want to create this column. So I want to create it in data 1. Then you want to use this $sign. So this $sign will show you every single column here. So in data 1, you have child column and Arabic column and English column as well. Also, it will allow you to create a new column that does not exist in the data set. So we want this column column to be called total. So by simply doing this, we created a new column called total in data one data set. Okay, so what this column be? So this column will be the sum or the addition between the total score of English and Arabic grades. So simply we can do this. We can call the English grade. I'm sorry, let's start with the Arabic grade. It's okay, it doesn't matter. So the Arabic grade and the English grade are within data one. So first of all, say data one, and this is where you will find the column in data one. Then again, use the $sign and just type, or maybe you can choose your column. So this is Arabic plus, because we want to add the Arabic grade to the English grade. So that's again data one, dollar, and English. Run this, and now open data one again, and you will see that there is a new column called total, and that's the fourth column, which contains the total value, the sum value of Arabic and English grade for each row. So this will do it row by row. So we got 45 plus 50, that's 95, 30 plus 40, that's 70, and 10 plus 1, that's 11. Okay, let's try doing this, but we will change data 1 to data 2. And this is where the problems will arise. So you will see that you cannot add 45 to 50 because in data 2, they are treated as a number. So you cannot add, it's not treated as a number. Yeah, so they are treating them as names, as characters. So let's say data 2, total, and that's data 2, Arabic plus data 2, English, and you will see that there is an error, and basically the data 2 is not treated as a data frame, so you cannot do any calculations on vectors like that. There is another way to do calculations for vectors. So yeah, that's it. This is why we said that the first way of using the data frame function is the best way to deal with this situation. Okay, so I'm going to move to the last part of this section for today's workshop, and where we will like to recall any element or any index within the table. So to do this, so let me just call this recalling an element from the data set. So to call any element in your data set, all you need to do is, let's say, for example, I want to get the second element, which is this one, from the second row, basically, or maybe the second column, the whole second column values. So to call an element from the data set, all you need to do is to write your data name first. So our data name is a data set name is data 1. So we put data 1, then squared brackets, and in the squared brackets, this is how it will be organized. So data, and you get the row, and then columns. So the first element is the rows, and the second one is the columns. So in data 1, if we want to get, for example, the first row, for example, the whole first row. So we will say the first row, number 1, and we will leave the second one, the columns, empty, because we want to get all of them. We want to get the first row, the whole first row. So we will not specify any column here. So you will see that the first row is Ahmed, and you get all the values here. Okay, what if we want to get the first row and the value in the second column, let's say. So this is the first row, and we will specify second column, yeah. So this is the first row, and this is the second column. So we will expect R to give us 45. So let's run this, and here we go. This is 45 as expected. Okay, so what if we want to call the second column, for example? So we will say data 1. We will leave the rows empty, so we will not write anything in it, comma, then the second column. And this will give us the whole second column. So 45, 30, and 10. And that's it. 45, 30, and 10 as expected. Okay, one last thing. So what if we want to call multiple rows or multiple columns? Again, how would you join? How would you combine multiple columns or row? Don't forget the key, and that's the C function, the combine function. It's a very important function, by the way. Okay, so let's assume we want to call the second row and the third row, all the values in both. So I will specify combine the second row and the third row, and I will leave the columns empty because I want all the values here. Run this, and you will see the second row and the third row of this data set. Any questions so far before moving to the packages? Do you guys have any questions? I can't see anyone have any questions, so probably I will just continue. Okay, no questions? Perfect. So let's minimize this and move on to our, I think I got one in the, okay. Thank you, Miriam. Okay, so moving to the packages, R packages. Again, the R packages are collections of functions and data sets developed by the community. And when we say community, so community refers to any person who has some interest in R. So it could be researchers, could be programmers, could be any person, could be you in future. So you can develop your own package if you want. And if you learn how to do functions and perform functions as well. Okay, so as I said, R has more than thousands of packages. So not all of them are installed in your device or on your computer. So sometimes you want to install packages to work on specific area or field, and that package is not like the base package in R, and you have to download it and install it. So you don't have to go through any website. You can install packages using R itself and using the functions. So you have two ways to do this. There is, like I would say, the an easy way, and there is a code writing way. I always prefer code writing. I actually find it much more useful, especially when I close the session and I want to load it again, or I want to restart the session. So I think writing the codes will definitely help you in future to restore everything as you want. Okay, so let's start with the easiest way. So the easiest way is to go to install and under packages window. So go to install, just type in your package name, and definitely you want to install it from the repository, the CRAN. And then just type in your package name. For example, here it's deployer, for example. and this is the library. So the library is default, and this is where you will find all of your packages stored into the R file. Okay, so click on install. It's already installed, but I have there is some update on it. So people regularly update the packages, especially the dplyr package is one of the most used package in R. So like every often you will see an update for that, and it will not update itself by automatically. You have to do it manually. Okay, so it's loading. And when you see this stop sign, that means you cannot work until this disappears. So once you see this one, that means R is running, is doing something. So you cannot work while this is loading. And it will take some time. The dplyr package is heavy, so it will require some time. So at the meantime, I will talk about a way of installing the package through the coding. Installing packages. So you can install packages by simply using the install packages function. But all you have to do is to write your package name between a quotation mark. So here we got dplyr, and this is our package. So this code is actually doing the same thing as install, and then write the package name and then install. So this will do the same thing. So yeah, it's downloaded now and failed. For what reason it's failed, I don't know. Okay, let's do it again. Sometimes you will see weird stuff in R and weird error messages. Okay, so install it. So I just want to show you that this does the same thing. So you don't have to worry about this. Okay, so any questions while we are waiting this? Any questions? You can type it in the Q&A, please. Let's wait for this. Okay, I think it's loaded. For some reason, it's showing not, but yeah, I think it's loaded. Why some functions doesn't need to download packages? Because they are built in R. So the packages are which are built in, they don't have to be installed really. So they are just used by anyone. Iman, I'm interested in regression package. Can R do so? Yes, there are some regression packages. I'm going to introduce one of them today, which is the psych package. And after that, you have to deal with the situation and try to learn how to do this. Okay, so we installed the package, but we didn't ask R to load it. So again, it will not be loaded automatically. You have to do it manually. So either by searching for the package, basically, and hit this one, or there is another way to do this is through the library function. So just say library and write down the package name, and that's it. So again, there is two ways to do this. There is no such definitely right way to do this or one way to do this. Okay, so Amani is asking from where I can get information about these packages. So basically and simply, you can use the packages window to do so. So if you type in your package name, for example, deployer here, and you will see here the package name. If you click on it, it will open up a window, a help window. You can see it's transferred to the help window. And you can see all the functions related to this package. For example, let's click on the count function. And by the way, you can see that count is counting observations by group. And you can see the documentation, R documentation for the count function, all the arguments, and how can you run the whole code. Okay. And yeah, this is a very good question, Amani. So you can get some information from this. And yeah, that's all about the packages. Any questions so far? Any questions so far regarding the packages? I can't see any questions, so shall I carry on? You are, good evening to Will. Yeah, you are most welcome. Thank you so much. Okay, so I will just carry on and let's see what else do we have. Oh, okay, so real data set analysis. Finally, we got there. So now we will do some real stuff with R, and that is starting by importing data sets into R. So how can we import data sets to R? Again, there are many ways to do so. Some of them are just straightforward ways. The others require some sort of coding. Again, I'm a person who prefers coding, but definitely sometimes it will save your time to write the code one single time and just run this code every single time you want to restore your whole project when you close your computer or and open it again. Otherwise, you have to import the data set every single time you want to work with the project again. Okay, so let's start with importing data set from the user-friendly view, click and view, and that you can find the import data set button under environment window. So click on that, and you can see there are so many extensions. So you can either import the data set as a text file, or from Excel, from SPSS, SAS, SAS, and Stata. So let's double check what is the data set we are trying to. Okay, I think we are trying to import the KU data. This is the KU data. So we got two extensions. We got TXT and Excel file. I will do both this time, but as a general advice, always save your data set as text file, because I really find the text file to be, how would I say, the lessons in the size, and it's a best way to import it in many different statistical softwares. So always try to save your data set as a text file. It will not take a lot of your a lot from your memory, your computer memory. Okay, so I will start with the Excel. So I would say import data set from Excel, and then click on browse. You will see your working directory here. asking install required packages. I will come back to this, Fatima. Okay, so KU data. Okay, so just wait until retrieving your data set. And here you can see your data set. So you can preview it before importing that to R. So here you got your column names and the rows. So it seems correct. So a name, you can name your data set whatever you want. I will keep it KU data. And the sheet is the default sheet. You don't have to play with this. So this will basically, if your Excel file has so many sheets, it will ask you which sheet it should import. And maximum number of rows, you don't want to play with this as well. You want to import the whole data set. You want to click on this if your if the first row is your column name. So you don't want your first row to be containing the column names. You want the column names to be actually in the column names. Okay. So this is ticked, should be ticked. You don't want to skip any participant. So if you change this one, it will skip the participant. If you choose one, so it will skip one. It will skip one, then give you the other one, skip the other one, and give you one, skip one, give you one, so and so on. If you change it to 2, so it will skip every 2. And NA, so if your data set has any missing values, R will definitely translate that to be NA when importing the data set. Otherwise, if you want specific number, you can just type it here. And I will show you another way to change the missing values number to a certain number as you like. Okay, and here you can see the code for importing this data set. So click on import, and here you go. This is KU data, and you can see your table here. Okay, let me just maximize this view. Some questions. Asking install required packages. So Fatima, I didn't quite get this very clear. So can you explain what package are you trying to, or what code you write to get this message? I have this message, warning in util install packages, unable to install package. That's weird. So are you sure, Imad, that you installed all, that you installed? So yeah, okay, Imad, probably you may want to install RStudio into a user that you can access. So here, when you see this down here, that means your user is not giving a permission for R to write anything into that file. So you want to give R an access to write files on your computer. But to be honest with you, I'm not sure how you can do this. So you may want to Google it and double check that. Okay, so I got something in the chat. Close R and reopen it as admin. I'm sorry, Najla, can you explain that, please? Maybe you are just referring to Imad about the same problem. Yeah. So Imad, again, I think, yeah, the problem is you are not giving R an access to your computer. So this is why R cannot write anything in your user interface. So you may want to log out or maybe log in again. Yeah. So thank you so much, Najla, for sharing this with us. Okay. So yeah, we load we loaded our we imported our data set from Excel, and this is one way to import your data set. So what if we want to import it as a text? So again, import data set from text, and then choose your data set name, which is kudata.txt, and open it. Again, make sure that the data frame is looking exactly like what you are looking for. But here there is a problem, and the first row is not the column name. The first row is contains the column name. I want the column names to be here rather than V1, V2, and V3, and so on. So you want to click on yes in heading, and here you can see that the column names transferred to be the first row in your data frame. Okay, and here also you can change the data set name. The encoding depends on how you encode the how you save the text file. Row names automatic. Okay, we changed this one. The separators tab, because this is how the data set was saved as a text file. Again, quotation. Basically, sometimes R will for the separator decimal and code, R will read this from your text file, so you don't have to worry about this very much. The NA strings, I will assign NA to any missing value. Otherwise, you can change this to be any number if you want. Then click on import, and this is how you import the data set from the import data set button. Any questions? Fatima's, I have already R installed in my Mac, so I didn't try it yesterday. Maybe that's why I can't import data set. Or maybe, so we are working on R Studio, Fatima. We are not working on R. But you can definitely import data set even though you downloaded R yesterday or whatever. So that should not be a problem for you. Yeah. I could not from text. It's okay. Yeah, maybe because Musabbah, maybe you didn't install the package. So to use the read Excel to import the data set from Excel, first you should install the package called install package. The package is called read. Sorry, we have to put it into quotation mark, read Excel. So first you should install this package, and then try to import the data set from Excel. I'm answering Musabbah question because he cannot import the data set from Excel. Maybe this could be the same reason for you, Fatima, as well. You didn't install the read Excel. You are much welcome, Musabbah. Okay. Okay. So what if we want to import the data set using the codes? So to read any file into R as a text file, first of all, you have to specify a name for this file. So I will call it data 1 maybe, okay? And then equals, you will use the function read delimiter, and then open up a quotation mark, double quotation mark, whatever, single or double, doesn't matter. And then you will put the file directory between the quotation marks. Okay, so we will go here and we will get the file path name, and here how you can get the file. So when I click on data one, you can see that here are my data set. Okay, so this is another way to import the data set by working by writing some codes. Okay, so any questions with respect to the importing data set before moving on? Khalid is asking, could they have a certificate? So Dr. Ahmed, whether you can advise Khalid on this or not, please.
There is no certificate for the workshop in ITAR. There is no certificate. Thank you.
Yeah, thank you so much, Dr. Ahmed, for clarifying this again. Okay. So it doesn't seem that you guys have any question with respect to the importing data set. Okay, so let's move on. So if we want to know how many participants and how many variables do we have in our data set, so simply you can go to the environment. You got 100 observation. That means you got 100 participants and 15 variables, so 15 columns. And this is simply how you get the number of participants and the number of columns in your data set. Otherwise, you will use some, okay, so this is how, okay. So yeah, otherwise you have to do some sort of coding. Okay, so that's importing the data set. Now let's move on to exploring our data set. Let's explore that. I think there is a question. The difference between the results of a traditional questionnaire and a modern questionnaire. I'm sorry, I'm not sure. What does this mean, Towel? I'm sorry, I'm not sure what do you mean, Towel. So if you can explain that, please. Sorry, exploring. Okay, so to explore our data set, we have first to install 3 different packages. So if you don't have them, you have to install them first. So the packages are the readr package and the dplyr. Sorry, the dplyr package and the schemr package. This schemr package is one of my best packages to explore data. Okay, so first I will give you 2 minutes to install the packages, the required packages, and at the meantime I will install them by myself as well. It's required to build our package, but it's not currently installed. Please download and install the appropriate version. Okay, so yeah, it seems like you are missing the R tools. So if you copy your problem, Imad, and this is the best way to learn how to solve your own problems in R. So just simply paste it in R. So you can see someone already has this problem before, and he posts that in our community studio, our studio community, sorry, and it was solved as well. So if you just click on that link, we will see what's going on. So it's not search currently installed. The install work fine. Should I be worried about the wording? Yes, although this might because binaries are not always available for OS and R versions. This means that you are going to install packages that need completion. You have also to install RTools in your system. Okay, so you have to install RTools in your system. I'm not sure why you are facing this Imad, but I guess you may want to look at this as well. Maybe this is if you are using Windows. Also, you can sometimes try different websites. You will definitely see a lot of answers here. Yep. Okay, so again, the same problem appears to someone else here, and what can I do with that other than downgrading my R version? So yeah, so you all the so you have to install. Yeah, so you have to install R tools. Maybe Windows is not installing R tools automatically. Could be a reason, or maybe you didn't give R a permission yesterday when you tried to install R and R Studio into your computer. So these two potential reasons could be happening to you. Okay, so I'm going to move to installing the packages. Again, you can install the packages one by one using this function, or you can always join them together, and just within one chunk of code, you can use the C function and write your packages here, deployer, and we get skim R. So this will install the three packages at the same time. Okay, again, you will see the stop icon here. You cannot work while this is here. You can always interrupt R. You can stop that by clicking on R on stop. And you may, or maybe not, but R, you may notice that R is not causing your computer to be super slow, because R is using one core only of your computer. No matter how many cores are available, R will always use just a single core to run the whole project for you. So this is not the case with SPSS and all other softwares, and this is why sometimes you are getting a lot of not responding error messages while working on SPSS and the other softwares. So this is something I like in R. So it's not causing my computer to be super slow, and I don't have to buy a specific computer to run my analysis of 10,000 people participating in my study. So R can deal with that easily with using single core only. And this is something that computer engineers will tell us the benefits of this. So if you give me a few minutes, a few seconds, basically, to install this. And at the meantime, do you guys have any questions? Okay, so the packages are installed now. I have to load them. So I will use the library function. but now you cannot use the library. You can't use C with the library, so you have to do it one by one. Library. And what's the next one is dplyr. The library. Skim R. Okay, so all of the packages are ready now, and now we can preview our data set. So the first function I want to introduce today is the head function. Let me just move to the PDF file. Okay, so the first function I want to introduce today is the head function. So the head function basically shows you the first 6 rows of your data set. So if you click on, if you type head, let me just, why didn't this? Okay, head and our data name. This will show you the first 6 rows. So this is the first 6. And because my screen doesn't allow, there is no space here. So it will just take another line to present the results. But again, it's for the first 6. You can always change the number of rows. So 6 is the default. You can change it to be 10 maybe. So it will show you the first 10 instead of 6. If you say 1, it will show you the first one only. So this is what the head function does. Second, I will show you the dem function. So dem function shows you KU data, shows you how many rows do you guys have and how many columns. So that's how many participants and how many variables are in your data set. So this is what the dimension function shows you, the dem function. Okay, and there are a few other functions. The glimpsy and summary skim will show you also the overall overview of your data set. So let's move to let's examine each of them. So first I will use the glimpsy function. Is it like this? Yes. Glimpsy. Okay, with the P. So glimpsy. KU data. Run this. So here you can see that you got 100 rows, 15 columns, and the ID and the values that are contained within the ID, gender, what are the genders of it here, and here it's integer, here it's character, integer. So it will show you each column as a vector, whether it's, so which type of vector it is. It's a good one. I don't really use it. I don't like it either. I have other functions that I like most. Also, summary is not one of them, but we will see what will summary show us. So summary will show us it's not always a good function, because here it is treating ID as a numeric value. So give you the minimum, the maximum, the median, the mean, third quartile, first quartile, the gender, it will give you the class. So it's a character, so it doesn't have any minimum, any descriptive statistics. So for age here, you can see that the minimum age is 18 and the maximum age is 30. The mean is 24 and so on. Okay, moving to the best function ever, skim. I really like this function, the skim function. So skim KU data. This is my best function for exploring data. Okay, let's run this. It will take some time. Give it a moment, and now you can see your data name is KU data. The number of rows are 100, and that's the number of participants. The number of columns is 15. you got 13 character column variable, and you got 2 numeric variable. There are no group variables, so no factors here. Okay, even though that gender is considered to be as a factor, a grouping variable. However, we didn't specify that. So since that we didn't specify that, R will not do that automatically. So I will show you later how would you do this. Okay, so now moving to each variable. So here you can see that there are no missing values. All of them are 0. All of them are completed. What's the minimum, what's the maximum, and so on. Okay, moving to the numeric variables. And the numeric variables, you will get such a nice overview of your data set. So for the ID, again, it will show you the mean. However, it will show you the standard deviation. And we need this 2 descriptive statistics to for when we write the reports for publications. So always the journals will ask us to provide the mean of the groups and the standard deviation for each group as well. So for age, we will report the age to be the mean or the average of the age to be 24.3 and the standard deviation of 3.68. And this is kind of the histogram. It will just give you an overview idea of the histogram. And that's it. This is how we overall we look at the data set. So what else do we have? Again, here we don't have any missing values. However, sometimes you may face in your studies that you got some missing values. So let me just create a data set containing some missing values. So let us finish up this page first before moving to questions. I will fabricate a data set to contain some missing values. So I will call it example 1, and that contains let's say C 1 to 10, and A again 1 to 10, and A and again 1 to 10. So I'm just creating a new vector, and that's age here. Okay, let me just make sure I'm getting this correct. Okay, so here you can see that I got 27, 28, 9, 31, 2. So we got 32 values, and we got 2 NA values. Okay, so how can we identify missing values? So identifying missing values. So first I created a vector with 2 missing values. Then I will identify NAs. So to do this, you simply want to, again, as I said yesterday, R is very simple. You can see that the syntax is easy to understand and to digest. So you have to say which. So you are asking R, which of the condition is true? So you are asking R, which is NA. So is NA function means that you are asking R which element or which index in this vector or data set has some missing values. And that's simply how you identify NAs. So I will say which is NA in example 1. So the 11th index or element and the 22nd element as well. So here you will, if you count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and yes, the 11th element is actually missing, and also the 22nd element is also missing. So here we will start from 14, 15, 16, 17, 18, 19, 20, 21, and 22. So yes, we got two missing values, and they are they are the element number 11 and the element number 22. Okay, and that's how you. This is how basically you you identify the NAs. Okay, so going to our data set, we know that age has a 0 missing values. So what if we ask R how many missing values, or where are the missing values in our data set in the age column? So we will say which is NA. So we want the age column. So where is the age column? The age column is in the KU data set. So first we will write the KU data set name, then use the $sign, and then write the age. So now you will see 0. So 0 means there are no missing values here in the age, and this is what we expect. Okay. So we can always remove or substitute the rows with NA. So let's first remove NAs. So again, I'm going to use the example 1 vector. Okay, so to remove the NAs, all you have to do is first to specify your vector name. So this is my vector name. It's example 1 because I want to overwrite that, and I said equals. Okay, let me show you this in a different way. So if you want to remove NAs from your vector or column or variable, first you have to write the variable name, and if it's within a data set, you should do it like this: KU data and then $sign then age. Then open a squared brackets and use complete cases function. Then write down your data set again. So by doing this, you will see that the NAs are removed. Now you don't have any NAs anymore here. Okay. However, when you ask R to give you example 1 data set again, vector again, you will see that the NAs will return. So the reason is because you didn't overwrite the new data set without the missing values on the existed data set. So all you have to do here is to either create a new data set and call it EG2, example 2, or you can just simply override this. So I will not overwrite it. I will create a new data set. I will call it EG2. And here, when you ask R to give you EG2, EG2 is the same vector without the NAs. And this is how you remove the NA. However, if you want to rename, so reassign new number, recode NAs to different number. Let's say, for example, 1000 or maybe 999. Okay, all you have to do is first specify, write down your data set name, then open squared brackets and write down the NA function again, EG1. So what I wrote basically is in EG1, in example 1, wherever this example one has an NA value, write it as a 999. So again, what I actually wrote here is in example number one, wherever example number one is NA, recode that to be 999. We'll do this, and we will ask R to give us example number one again. And now you can see that the NAs were substituted and recorded by 999. Okay. So any questions so far? Any questions? Why I can't see results in my console? Fatima, because you have to run this. So to run this, if you are using Mac, you should click on Command and Enter. And if you are using Windows, you can click on Control and Enter. Otherwise, you can just highlight this and click on Run here. So there is like Run button here. Fatima, I hope I answered your question. Okay, so you are welcome, Fatima. Okay, so now let's move to our data set again. So this is our data set. So we got question number 1 to question number 6. They are representing the anxiety scale. And question number 7 to question number 12, they are representing the depression scale. So for this one, we want first to recode this strongly disagree, strongly agrees, and so on to be numbers. So to do this, recoding. So to do this, first of all, we have to specify in which row and which column we want to recode, and whether you want to save you want to overwrite the existing column, or you want to create a new one. So by doing this, KU data Q1 equals, so whatever we are recoding here will be overwriting the existing Q1. So if we don't want to do this, we can simply say Q1R. So Q1R does not exist in our data set. So that means it will create a new column called Q1R. And this is how I like to do things in R. I don't want to mess up with any column I got. So I always try to create a new columns rather than just working on the existing one or overwriting the existing one. Because once you click on run, you cannot come back. Otherwise, you have to rerun the codes again and re-import the data set, and that's too much, I guess. So recoding into new columns will definitely be enough. Okay, so what you are trying to recode, now we will fill out this function. So first of all, what we are trying to recode is the values in Q1 column. So let's specify that. To specify Q1 column, first of all, ask yourself, where is Q1 column? It's in the KU data set. So I will say KU data, the $sign, then I will write down the KU1. So here, where the values I want to recode are. Okay. Then write down your values that you are looking to recode. So first, we want to recode strongly disagree. And remember, strongly disagree is a character. So R will not understand that this is a character unless you put double quotation mark. single or double, doesn't matter. Again, I like to use the double, so it's a personal preference, I would say. So strongly make sure make sure that you are writing it correctly, and pay attention to that. So strongly disagree, and you want to convert this to 0. So by doing this, let's run this only. Plus, hold on a second, please. What's the problem here? Strongly disagree. Okay, maybe we don't have to. Oh, okay. So we have to recode the why the replacement x and replace values treated as an a. Okay, so it's giving us a warning message that any value that was not recoded, because we are, remember, we are creating a new column. The new column has no values in it, so it will not simply take the other, I mean, agree, disagree, and strongly agree simply from Q1 to Q1R. So if you open up your data set again, you will see that all if Q1 is either strongly agree or disagree, anything rather than strongly disagree will appear as an NA. Otherwise, they will be disagree. We don't have any disagree here. Oh, really? No one disagreed with that? Strongly disagree. The third one should be okay. So I think we should specify all values first. Okay. So strongly disagree. Yes. And then we got disagree. We'll record it to 1, and then we got agree 2, and then strongly agree to be 3. For some reason there are, this is weird. Okay. Let's see what's going on. There is a problem with the strongly disagree. Am I writing it correctly? Strongly disagree. Yeah, it's correct. Oh, okay. So no, it's incorrect. So this is the reason. Again, I was just telling you to pay attention to that, but myself, I'm not paying attention to the writing. So there is a typo here. I wrote it as a disagree rather than disagree. So just change this one to disagree, and now it should work. Okay. What's the problem with, again, disagree? I'm not sure why I'm writing this in a different way. Okay. So now you can see that all the values are converted to 0, 1, 2, 3. And you have to do this for every column. Okay. So any questions? You wrote this, yeah, right, Cassinia, thank you so much. Yeah. So I didn't pay attention, maybe because I'm still fasting, not concentrating enough. So yeah, you guys are right. Yeah. Okay. So all you have to do is to copy paste and just change the numbers from 1 to 2. And now you can see there is a new column called Q2R. And you have to do this for all the data set, for all the other questions. Okay, so I will give you an exercise here. I will just copy this and paste it to you guys. I'll give you an exercise here to recode all of the variables from Q1 to Q12, and then try to sum try to sum without looking at this one. Try to sum questions from questions from, I will specify it here. So try to create a new column for an anxiety scale, and that equals from question 1 to question 6, and depression scale, and that's from question 7 to question 12. So I will give you 5 minutes for this, and then we will go through this one together. Okay, so I got some answers. Okay, so Najwa did this. Let's see. Okay, first of all, let me just recode the. I don't think that this is correct, Najwa, by the way. So, I will do this. So first of all, I will have to recode all of the variables. And by the way, if you are used to R and you know how to deal with the function, so you don't have to do this manually every single time. And there are some loops, but this requires a lot of advanced programming, I would say. So this is not our case here. Maybe in future, hopefully, if this is something you are interested in, I will share with you a link before the end of this workshop to ask you whether in future you guys need some advanced workshops, and that will be organized by Dr. Ahmed, hopefully, inshallah. Okay, so first of all, I recoded all of the variables, the questions, and now I just want to create a new column. I will call it anxiety. So I want it to be in QData dataset. So that's QData, $, anx. And I want this to include the sum of from question number 1 to question number 6. So QData Q1 R plus. So I'm going to copy that and just paste it every single time. I know it's not the best way to teach R, but I'm trying to be as fast as possible just to move on to the next section. I know we are running out of time now, and I don't want to take a lot of your time. Okay, so I created a new data set containing the anxiety results. Here you can see them, and that's literally the sum of the values from question number 1 to question number 6. I'm going to do the same thing, but I will call it I will call it depression now. Depression, and that's from question number 7, 8, 9, 10, 11 to 12. Okay, so I created a new column again called depression, and this is the values. Okay, I guess that's it for exploring the data before moving to the real analysis. I would say real data set analysis. And by the way, this whole data set is fabricated by me. And this is one of the bad thing about R. So you can fabricate the samples, you can fabricate the results. And I think journals are struggling with this, as I guess, and hopefully not, but a lot of researchers are aware of this, and they can just simply play with the results. And as you can see, guys, this looks real. So it doesn't look like it's a fabricated data set. We can see age, ID, different questions, and also I can play with it. I can shift them toward the mean. I can shift them to be skewed to the left, skewed to the right. I can play and do it in many ways. And this is how the simulation studies are done in R as well. So how did I created this? So I create a column containing the ID, the gender, age, each column separately, and then I joined them together to be in one data set. Yep. So this is something you don't want to do. Actually, you don't want to do it. Actually, yeah. Okay. So far, any questions before moving to the real data set analysis, to real study? And this study was done by me, by the way. Any questions so far? Do you guys have any questions? Okay, so let's carry on and move to the real data set analysis. So approximately this will take around 30 to 45 minutes, I guess 30 minutes in the ideal way. So is that okay, Dr. Ahmed? Can we take 30 minutes?
Yeah, sure, sure. Do you want now?
Okay.
Or when?
I think so. So do you guys want some break, maybe, to walk around a little bit, so not sitting for 2 hours on your computers? You want break for 10 or 5 minutes and come back?
Okay, do you want after the break, Dr. Nasser, open the session for Q&A?
No. Because we will start a new, basically a new section,
Okay,
and
so
that is analyzing a real data set.
let's have a break for 5 minutes. We'll back in 5:25. So 5 minutes break.
Okay, perfect. Sounds great. Yep. Yeah, and you can just read the hypothesis if you guys want. Hello, so we're back. I hope everyone is here. Okay, so let's do some real analysis with a real data set right now. So it's not fabricated, I promise right now. First of all, so to analyze this data, I was basically collecting data, basically collecting questionnaires on self-esteem, life satisfaction, and social media addiction scales to test the following hypotheses. The first hypothesis was whether there is a significant negative correlation between social media addiction. Social media addiction is SMA, and self-esteem is self, and self in Kuwaiti adults. And the second hypothesis was there is a significant negative correlation between SMA and satisfaction with life. And the third hypothesis was there is a significant difference between the average social media addiction among gender, and that's male and female. And the fourth and last hypothesis was there is a significant difference between the average social media addiction among different usage groups, and I will show you what does the usage groups mean. And first of all, as a data analyst, you should always explore the data, but before exploring the data, you have to import the data set to your software. Okay, so the data set is called study one. So I will move to import data set, and I think that's saved as a text file. Yeah, okay. So this is text file. Line 1 did not have 31. Okay, so we have to change the heading. Yep. So once we change the heading, this error message will disappear because it was dealing with the column names. And yes, this is how the data set will look like, and this is what we are trying to work on. Okay, so let's import this data set. Yep, and this is, we got ID, basically the ID. Start time is when they started the survey, the completion time where they completed the survey, their email, and it's anonymized by the system. Consent, whether they consent to participate in this study or not, and to confirm their nationality, because the study was dealing with Kuwaiti adults only, so they have to kind of to validate the data collection process. I have to ask them whether they are Kuwaitis or not, and to confirm it. Okay, and we got gender, and that's 1 and 2, 1 for male and 2 for females, and the age. Okay, we got usage. So usage is basically whether they use the social media platforms less than 1 hour, and I guess, is it less than 1 hour? I forget, to be honest with you. Yeah, so it's less than 1 hour, and 2 is basically 2 to 3 hours, and 3 is more than 3 hours. Questions number 7 toward 12 are dealing with the social media addiction scale. So they have to be summed up to reflect the SMA subscale. I'm sorry, the scale. And self-esteem scale is actually represented by questions from number 13 to 22. And last thing is satisfaction with life scale, and that is represented by questions from 23 to 27. And that's it. We don't have to recode anything, I guess. Yes, I believe so. Okay, and now I guess we are ready to explore our data set. So let's do that. To explore your data set, what is my favorite, my best function to explore the data set? Who can help me with that? Let's see the chat. Skim, that's correct, Musabbah. Right, Najlan Musabbah, you are following with me. So Skim from the Skim-R package is my favorite function to explore the data. So I'll say Skim, and then I will write my data set name. That's study 1. Let's maximize the screen and try to give some space here, because I guess it's going to be too much. Okay. Yes, here we go. I guess we have a question. Yes, Alex, right, correct. So we want to use Skim, correct. Okay, so this is our study. I'm sorry, this is our data set. The name of the data set is study 1. We got 528 participants. We got 30 variables. Among these 30, 5 of them are characters, 25 of them are numeric. Okay, and no missing values here. No missing values here as well. Okay, and we want to look at the age. So age is 26, the mean age is 26, and the standard deviation is 10.4. Okay, and here is how the histogram of the age looks like. Otherwise, all the mean and the all stuff related to the other things are not necessarily here. Okay, so yep. So we looked at the overall structure of our data set. One more thing I want to introduce here is the lapply function. So the lapply function is a function that shows you the class of each variable. Okay, so here we want to show the class of each variable. Okay, so why we want to look at this? Because when you go back to your data set, for example, gender is a factor. So gender is not actually a numeric variable. Even though it has numbers from 1 to 2, 1, 2, 1, 2, 1, 2, it's a factor, male and female. So R will not realize that automatically. So we have to check first whether the class is correct or not for each variable, and then we will move on from this. The same thing applies for usage as well. So you can see that the numbers are 1, 2, 3, but we are actually referring to groups. So they are factors as well. So factor means group, the same terminology. So lapply or lapply, and that's study 1, our data set, and the function class. Okay. Lapply. So, and that will show you. Okay. So ID is integer, start time character, completion time character, should be time or date. It's okay. Okay. So moving to gender and usage. You can see that gender here is integer, but it's not true. Gender should be specified or realized by R as a factor. However, R realized the numbers here to be integers. Okay, how can we change this? How can we overcome this issue? So we want to convert classes of gender and usage to be factors, and that's characters. Okay, so to do this, first of all, where is the problem? The problem is in the gender column. And where is the gender column? The gender column is in the study 1 data set. So first of all, specify the data set name. Then say where is the problem? So it's in study 1 data set, and specifically in the gender column. And we want this to be as factor, exactly as this. So we want this to be exactly as factor. Okay, we want who to be exactly as factor? We want gender, which is within the study 1 data set, to be as factor. Okay, so then we will say again, study 1, gender. So if I want to transfer this, to translate this this code to a text, to put it in a context, basically this means that I want the gender column in the study 1 data set to be treated as a factor, and save this, overwrite this in the gender column. If you run this and you run lapply again, you will see that gender has been converted to be factor. And this is very important before you start your analysis, because basically you need, you want to do some deep independent sample C test, and that requires some groups, and the ANOVA as well, which requires another groups as well. Okay, we will do the same thing with usage. However, I'm going to change the gender to be usage, and gender here to be usage. Again, make sure that it's correct, and yes, it is. Usage is a fact right now. Okay, so any questions before moving on? Do you guys have any questions? Okay, no questions. Perfect, sounds great. Okay, no questions. Okay, so the next step, as you may notice, I think there is a question: how can we dummy code gender in R? So do you mean, Musabbah is asking, how can we dummy code gender in R? So do you mean to recode the factors? I mean to recode the numbers to be male and female, or vice versa? Because usually we dummy code when we have multiple groups, not just two. So we want to set one group to be 1 and the others to be 0. Okay, so Musabbah, doesn't matter whether it's 1 or 2 or 0 or 1. It's just linear transformation, so it doesn't matter really which code you are giving to which group. However, if you want to change so if you want to change the where is it, study 1. So if you want to change gender here, that is 1 to be 0 and 2 to be 2 to be 1, I'm sorry, you can just simply use this. So recoding to 0 and 1, and that is, so we want to create, and I don't want to mess up with this one, so I will say gender M. I will call it gender M. Okay, so recode. What's the data set name? It's study 1, and we want to recode values in gender. Okay, I think we will face an error here. Hopefully not, but I guess we will face an error here. Let's just move on. So we want 1 to be 0 and 2 to be 1. Yes, we will face 0 as I suggest, because now 1 and 2 are treated as factors. We just change them, so we have to redo it again and assign them to be numeric. So I will change this to be as numeric. Okay, and now, oops, hold on, what's the problem here? For what reason we are getting this? Hold on, let's figure this out. Recode, study one, gender. Maybe we should do it in this gender. Should not, no. Hold on. Okay. Okay. So you have always to put the what you are trying to recode into quotation. So if you go to study one now, you will see you created a new column, and the values here are zeros and ones only. I hope this helped and answered your question, Musabbah. Yeah, I hope it's answered your question. Okay, Najwa had a question. What is the meaning of integer? Is it a character? No, integer basically means number, Najwa. This is what integer means. Integer means number, numeric, okay, numeric value. Great, Musabbah, great, okay. So let's do this again, okay. And that was for Musabbah. Okay. Now, as you guys noticed before, the social media addiction scale is represented by questions from 7 to 12. So we want to sum up the values from question number 7 to question number 12 into one total score. So I did this before, and we did it so many times. I don't want to waste your times, guys. And that's creating total score for each scale. Okay. So I had this previously. Okay, just copy paste it. And yes. Okay, so I run all of them. I created now 3 columns containing the SMA, the self, and satisfaction variables. I'm going to share these chunks of codes with you guys in the chat so that you don't waste your time and write down every. Okay, let me do this. Sorry. Okay, so so we are talking about this manuscript, and I got the decision on this manuscript basically. That's funny. What do you think about it, Dr. Ahmed?
Yeah.
This is so funny. We are just talking about the same data set that I used on the manuscript that is submitted to the cyber psychology journal. I will look at the email later. This is funny. Okay, so I will write down every code. I hope it was accepted after 3 different comments. Yeah, 3 different rounds of comments and reviewing and amending. So hopefully this time it will be accepted. Okay, so now we created the data set, and it's ready. I guess it's ready to be analyzed. Okay, so let's move to the file again, and let's see what else do we have. Okay, so again, we used the skim function, and we used the summary as well, but we created a new, don't forget that we created a new total score. So we want to do skim again to look at the newly created columns. Okay, so skim again, skim study 1. So here you can see that, okay, this is too small. Let me just give it a chance to, yep. Okay, so now we got these three, and you can see the histogram of each of them. And also, you can see the mean of each of them with the standard deviation associated with that mean. Okay, so this is how you get the descriptive statistics for each scale. And let's move on to the histograms. So I guess there is a question. Are for the sum, not the mean. Yes, Musabah, they are for the sum. Did I say mean? Maybe by mistake, I'm sorry. I was just summing up the questions, the values for each question to reflect the original scale, to get the total score, basically. Yeah, they are total score, not mean. It doesn't matter whether you got the mean or the total score here, because it's from my statistical perspective, it's just a linear transformation of the value of the total score. So it doesn't matter whether you, I mean, it doesn't change the results if you decide to go with the total score or average the scores. Doesn't really matter, even though many people really think that they are different, but no, it's not. Trust me, I'm a statistician. So it's just a linear transformation. Okay, so let's draw some histograms, even though we got the histogram, but it's a little and we cannot export that out of R. So histograms, you can easily create an histogram using the hist function and just put down your variable. And that's, for example, let's do it for social media addiction scale. So that's SMA. And where is SMA? SMA is in study one. So we will say study one, SMA. And draw the histogram. Hold on for a second. By the way, R is only working slow when I share my screen. I don't know why, but it's super fast usually. So it's not as slow as this. Okay, so here is the histogram. And you can click on export. You can save the image or copy to clipboard, and you can maintain the width and height and then update. So for example, if we want to change the height to be 400, update the preview, it will change. Do 600, update, it will change, and so on. So you can play with the width and height as well. Okay, you can also change the bins, the number of bins, the number of cutoffs here. You can change the title, you can change the X lab label, and you can change the Y label as well. And you can do everything within this Hist function. So for example, let's say we want to change the title. To change this, let's go to question mark Hist. Let's see what's going on here. And what can we do? There's a question. Okay, so this is histograms. Yep, so we got the histogram. So we got the breaks. If we want to change the breaks, if we want to put frequency rather than density or probability curves, we can change the main. So main basically means the, where is it? So main is basically the title, and the X lab and Y lab are the labels for each axis. So I will say main, I will call it social media addiction histogram or so on, whatever. You can change the X lab. Sorry. You can change the X lab label to be social media addiction. Sorry, addiction, social media addiction scale. Maybe you can change the breaks. and that's to have more intervals. And you can also change the color. I want it to be blue, for example. So I said color blue. Let's run this one. Color red. It's red. Color purple. And it's purple. If you say navy, so R will understand that, I mean. Okay, and this is how you create histograms. Let's move to box plots. So to create a box plot, first of all, you should use the function box plot and then specify your model. So your model, you are looking at the social media addiction scale between gender. So we will use this symbol, and that's between gender. And our data is study 1. And let's run this, and you will get the box plot. Again, you can always change the pay-per-view. You can change the title. You can change the X lab and Y lab as well. So this is how you get the box plot, and you can see that there is a difference. It could be significant toward females, and this is how you actually perform the box plot analysis. I know we are run out of the time, but we have a lot of stuff we didn't cover yet. So what are your thoughts, Dr. Ahmed? Shall I just go over them very fast? Dr. Ahmed, are you with us? Okay, so I will do my best to go through this very fast. I'll do my best. Okay, so getting alpha values, internal. Okay, so first of all, you need to install the package psych. I already installed it, so I will just load it. Psych. Okay, then you need to create, sorry, you need to create between SMA and oh, definitely Najwa, we didn't finish yet, so we will not examine that through the box plot only. I'm going to carry on. Okay, so first of all, we should subset each subscale and separate it to get the alpha values. So by doing that, I will show you the first one, and then we will just carry on. So to do this, first of all, you need to get the variable names in study 1, and I will tell you why we are doing this. Okay, because if you remember, if you can recall, question number 7 to 12. Here is a question number 7 to 12 are reflecting the social media addiction scale, and they are starting from element number 10, as I explained yesterday. So element number 10, 11, 12, 13, 14, 15. So 11, I'm sorry. So element number 10 to element number 15. So this is how we want to extract these columns. So we want to create a new data set. We will call it SMA1. And this data set will contain or will consist of values from study 1 data set. We will get all of the rows. So we will just ignore the rows. We will not put anything in the rows. We will keep it empty. And we will get the columns from 10 to 15. So now we created a new data set, consists of these these values. Okay, we will do the same thing for self-esteem and satisfaction with life. I'm going to do this super fast, and let's share this with you as well. Sorry. Okay. So yes. Now we got 3 different subsets, and we will use the alpha function. So alpha SMA1, and this will show us the reliability, the internal consistency value for this scale. It's 0.7, the standardized alpha, and it will also give you the lower alpha and the upper alpha, the 95 confidence interval, and the reliability if each item is dropped. So we can see that all items will result in fewer and less alpha, except for the first one. So if we deleted the first item from this scale, the reliability will goes up, and we will get item statistics for each item included, and the number of missing values, and so on. I'm sorry, non-missing response frequency. This is very advanced if you are familiar with factor analysis and such stuff. We will do the same thing for other variables as well, other scales for self-esteem, for example. So it's 0.83, and that's between 0.81, 0.85. And this is how we calculate the alpha value. I provided a reference if you want to perform factor analysis. It's a good reference if you want to do factor analysis with R. You can look at it later. Okay, I'm sorry, I will keep going on. So testing the hypothesis. So the first 2 hypotheses, we're dealing with whether there are significant negative correlation between social media addiction and self-esteem in one hypothesis, and with life satisfaction in the second hypothesis. So we will use this code here. Okay. So basically this is, I'm telling R to perform correlation test between social media addiction and self-esteem, and to use Pearson correlation. You can change this to be Spearman if you want. Depends on how you will proceed with this one. So I will run it, and here we go. We got a correlation of negative 0.32, and this correlation is significant, and this is the t-value and the degrees of freedom and the p-value. So the p-value is 2.11 to the power 10 to the power minus 14, and that's very far away from 0.001, far less, I mean. So that means the first hypothesis was satisfied. So I want to change it to the second hypothesis. I can do the same thing. Satisfaction. Okay. Again, we got a negative correlation, and that's also significant. Okay. And what if we want to plot this? So we can plot this by the function plot. So plot study 1 SMA study 1 self, and you will get the box plot. It's not very clear because we have a lot of participants here. You are very welcome, Dr. Sertaj. Okay, there is also another way to do this by pairs. I'm not going to go through this one. Okay, I will perform the t-test now. So the t-test basically, first we will start with the assumption of homogeneity of variance, and that's through the function variance test. And you want to specify your model. Again, you want to compare the social media addiction across gender and the data set study 1. Okay, here's the ratio. The p-value is greater than 0.5. We can assume that the ratios are the homogeneity of variances assumption is met. Definitely we will. Okay, definitely we will. Okay, we can also get some descriptive statistics about each group here by the function described by. So you got the mean, the standard deviation, and so on. Let's move to performing the real analysis. So the real analysis, again, by using the t-test. So by using the t-test function, again, specify your model, and your data set is study 1. The variance equal is true because it's assumed through the variance test here, and it's not paired sample, it's independent sample, so this should be set to false. Run this, and here you go. So you can see that the t-value is minus 4.4, degrees of freedom is 526, and this is the p-value less than 0.05. And with that being said, this means that the differences are significant between females and males, where females scored higher than the male group in the social media addiction. With that being said, so we can say that females are more addicted to social media than males. Okay, we can also compute the effect size. Computing effect size, Cohen's d, and the effect size is 0.44, and the lower asymptote is 0.24. The upper asymptote is 0.64. And yeah,
we need to wrap it up. Then we have 10 minutes for a question before we end this workshop.
Sure. So I got an ANOVA and linear model modeling after that. So I guess it's a good idea to do this later in a very advanced workshop and to start with it. So I guess by this, it's a good start for you guys to play with R. And one last thing I want to do is first, let me just share a link with you guys. I would really appreciate if you participate in this questionnaire. It will ask you whether you benefit from this workshop or not, and some few questions about the future workshops. If you want us to do some advanced, and whether you have any suggestions. So I will give you 2 minutes to fill this out and receiving your questions as well. And before ending this workshop, I will show you one thing, and that is a thing that I said yesterday. You don't have to be a programmer to play with R, because R is just simple as working with R scripts. So I will show you how to do this, but please, if you have some time, can you just participate in this link and this questionnaire. It will ask you some few questions, will not identify you. I don't know if the link is opening with you guys or not. It doesn't seem to work with me. Maybe with you. Is it working with you guys? No, I don't think so. It's not working. Okay, let's see. For some reason, I can't Oops.
It doesn't work, Victor.
Yeah. Let me just do this fast. And by the way, so I'm ready for your questions, guys. If you have any question.
If you have a question, you can write it in Q&A, or you can raise your hand and ask Dr. Nasser directly.
Yep.
So it's up to you.
Anyone can respond. Okay, show the URL. Yeah, welcome. Yeah, you can definitely rewatch it in YouTube, Bahi. We miss you, by the way. We miss your participation in the workshop. Okay, so yeah, I will give you 2 minutes to fill out these 3 questions. So hopefully by the time I can get some questions to answer. And sorry for taking too much, Dr. Ahmed. You know, I am super
لا هذا اللي يقول مصائب قوم عند قوم فوائده، وانت غيرت الوقت وما كفى يعني. So
yeah.
Thank you so much for your time. Inshallah, if everything is okay, we can have another workshop, or maybe 1 day for an advance, or 2 days for advance in the future for R. But everything, inshallah, everything is okay. Just let's see if anyone have any question. Any question, guys? If you have any question, can raise your hand and ask Dr. Nasser directly, or if everything clear, that's fine. Fatima, yes, it works.
So I will just show you one last thing. I promise, last thing. I love teaching R. So this is why I'm taking too much time explaining a lot of stuff. So excuse me for that.
No, that's fine. Everyone, I think, like your workshop, very clear and useful as well.
Thanks. Thank you so much, Dr. Ahmed. And again, I would like to take the opportunity to thank you very much on all of your efforts with ITAR group. We really appreciate your work.
Thank you too.
To the community. Yeah. So I will show you just one more thing. So again, you don't have to be a programmer to use R. So R can be used easily by just amending and editing your codes based on your data set. So for example, if we want to perform ANOVA and we don't know anything about R, so I will give you an R script containing these lines only, just these, the highlighted lines, and you will have to change the data set. You will change the variables depending on your data set. So for example, now I want to first of all, I want to fit a model, an ANOVA model, and that is ANOVA equals 1. I will call it ANOVA equals 1. And this is study 1, my data set. I want to do ANOVA test, and this is my model. It's SMA across usage groups, and I fitted this. Okay. Second thing is, could not find function ANOVA. Okay, because I guess and where is ANOVA test? In which package? I'm sorry. ANOVA test in R. ANOVA test in R is in no. Where is it? Oops, I can't find it. You know. R star. Okay, so it's in this package. Definitely, I will give you the packages when I give you the codes. So don't worry about this. So let's fit the model first. Okay. We fit it, and then let's move on to post hoc, if there is any post hoc model as well. And now we want to load another package, which is called gplots. Gplots is one of the useful packages. And here, you only have to change the variables, the things in green, to basically your variable. And you will see how R will give you the results in a very nice way after fitting the model. So I will change this to be my factor, which was usage. And then here I will add my data set name, which is a study1. And in X, I will specify my factor again, which is usage. And in Y, I will specify the variable of interest, which is the numerical variable, which is in this case SMA. Okay, sorry, it's SMA. Stat, that's correct. Your ANOVA model here. So anything after the hashtag, you should amend it. So my ANOVA model is called ANOVA1 here. Okay, so this is ANOVA1. And let's run this and wait for a few. Okay, what's wrong here? Do this and then gplots. This is weird. Okay, what's wrong with this one? Okay, let me just try to copy and paste it. Maybe I'm doing something incorrect. Sorry. Excuse me for just a second, please. Yeah, because everything was in a separate line. Okay, yeah, this will work now. Okay, fit this, confine library gplots. Okay, so I couldn't find the function. I'm sorry, I have to install it again in R. This is the last thing I promised. So this is in ggpubr, one of the greatest packages as well. Okay, it's installed now. Again, let's fit the model and run the whole thing and wait for a few seconds, and you get the whole results. So you get the ANOVA test, the F value of 74, first degrees of freedom, second degrees of freedom, the P value, and also you get eta square, the effect size. And here you can see that the differences are significant among all groups. So for example, here between 1 and 2, between 1 and 3, and also between 2 and 3. So this is very nice overview of your data set, and this is how you can look at the results as well. So the only thing I did is to manipulate, to amend the codes based on my data set, and I don't have to be a programmer to do this. I just need to understand how the codes are looking like and how to change them. That's it. And you can definitely be proficient with R by practicing always. So again, thank you so much for choosing to attend this workshop. I would also like to take the opportunity to thank Dr. Ahmed again for hosting this workshop. Excuse me if I didn't meet your expectations. Excuse me if I take so longer time than expected as well. I really appreciate your participation and your kind words as well in the chats. I wish you all the best in future. And if you guys need any help in future, if you want to think with R, you can either reach me at my email or maybe my social media accounts. So I'll be more than happy to assist anyone and to answer your questions, definitely. And all the best, and thank you so much again. I wish you all the best in the future, and Ramadan Kareem for everyone who's celebrating and fasting Ramadan.
Thank you so much, Dr. Nasser, for صراحة informative and very useful workshop during those 2 days, yesterday and today. I know it's before Iftar and you did a very good job. You start with us from scratch until in this level today. So really thank you very much for this workshop. And I know when I asked you without arrange this workshop from long time and you agreed, so I really appreciate that, Dr. Nasser, and appreciate your time and effort. It was really useful for me as well. I received many emails. Thank you for this webinar, and also who didn't attend today, they will receive an email for the link that it's recorded, so you can watch it in your own time as well. So thank you so much again, Dr. Nasser, for accepting my invitation and doing the
My pleasure.
Really appreciate it. Next week, inshallah, we'll have 2 webinars with Dr. Randa and Dr. Wael. Each one will talk about a different topic, which is on Thursday and Friday. I will announce it, inshallah, tonight or tomorrow morning for registration. I already put in the chat all the accounts for registration. And inshallah, see you next week. Thank you again, Dr. Nasser. Thank you who's joining us today, and thank you for who's watching us in the YouTube as well. Really appreciate it. Thank you so much. Shukran, Dr. Nasser. Shukran.
Thank you so much. Thank you. You're most welcome. Take care. Bye-bye.